Okay, good evening, everyone. It's nice to have all of you here today, and I hope the rest of our community members will be joining in as we progress. So we wouldn't want to waste too much time. Thank you, everyone. Mr. Dennis, thank you for joining in despite your busy schedule. And also to Arthur, my friend, thank you for finding time to come speak to us this evening. So our event this evening is the usual 1 hour discussion and talk that we have every month. And today we have with us Arthur Kaza. He's the lead data scientist for IAG, and also he's the Google Developers Group Kinshasa organizer. I think I've known Arthur for like 3 years now, 2021 to 2022, although we became closer since last year, but we've been a little bit of friends since 2021, when we both were GDSC leads for our various campuses while we were still in school. So Arthur, it's very, very nice to have you here this evening, and he'll be speaking with us. He'll be speaking with us to us today on how to chart your Firestore data with PaLM API and Firebase. He made emphasis of the food edition, I had to add it there. So Arthur, the floor is yours. You can go on now and take your presentation. Thank you very much once again. Arthur?
Hello, everybody. Can you hear me?
Yeah, I can hear you.
Yes, we can hear you, Arthur.
Okay, that's fine. So I'm very glad to be here, to have been invited by Janine, a great friend. I'm very happy to share with you today about this topic, this amazing topic. So I didn't have time to finish my presentation, so I will just present. There is not just my picture on the first page, but you can see me, so no need of my picture. Here it is. Let me share. That gray. Okay, that gray. So we're gonna talk about chart your Firestore data with PaLM API and Firebase. I want to start first by just with some definitions to get things on the points. The first thing I want to say is just about what is PaLM, because many persons, you even already hear about it, but many persons don't know really what is it. So just to fix things at the beginning, well, just to know that PaLM 2 is the next generation large language model that has been built by Google. It's about the legacy on research and machine learning. The very different, the very specificity of PaLM is that about the advanced reasoning task, including code, math, classifications, and question answering. And also, I've tried it before this meet. I can confirm you that PaLM have a great translation and multi-language proficiency. And about natural language generation, you even already hear about all stuffs around LLMS, but PaLM is also one LMS, but developed by Google. Like I've said, the approach that Google have used to build this LLM is very amazing, because the approach is based on the potential to harms and biases, the capabilities to downstream use in the research in product application. We're gonna see together this evening one application, how this solution can be used via an integration on an application. So let's go. let's make it much fun and together. So to make it just fun, you even though already seen this picture. This picture is just about different developers habits. When it's come to develop something, you're gonna make many search. You're gonna look about what will be the best solution for your application or for your software. So it's really headaches and many time to use. So in this presentation, I'm gonna help many developers to find some tricks that can help them to integrate PaLM on their application. And the use case will be for the food edition. So dev perspective, how can I add the LMS to my apps? A great question. So like you can see the slide, I've used it for the Dev Fest. It was my presentation on the Dev Fest at Luanda. So let's go. First, like I have defined PaLM, we're gonna go with what is the LLM. So I want this presentation interactive, so I can interact with the public. You can give your answers, and together we're gonna go. So this slide. Public want to go through? Anyone want to go through? To try? Just try. So don't be polite. Don't be shy. We're gonna go together.
Sorry, Atos, like what was the question again? We didn't get that part of the question.
Okay. I was saying that I want this session interactive. So I was asking to ask what we think about LLM. What is an LLM? What do us know, each of us? Anyone have an opinion, a thing? So we can go through it. Anyone want to go to try? Okay. What is an LLM?
Okay, LLM, large language model, if I'm not mistaken. You're muted.
I've forgotten. Sorry, I forgot it. So I was saying that great. That really great. Yes, it is. And then another idea, an example. Anyone have an example of LLM? An example? Don't be shy. Don't be shy. So let's try together to demystify it. So LLM, like Benjamin said, it's a large mod. It's about AI in general. It's about a model used to make it easy. We're gonna take an example. It's like a son which is growing. When a son is growing, he has to learn a language. So he has to be trained on this language. It's not really simple for this child to learn. But how a child can learn about a language? Any idea how a son can learn about a specific language? Any idea on the assistants? Denise, Benjamin, Dasglow, Joel? Any idea? Come on, Benjamin.
Okay.
Come on, please.
I think the way we learn, say for language or like pretty much everything, one is by repetition. Then
exactly.
Yeah, by repetition.
Great points.
You said what?
Great points.
Yeah, and again, by seeing many examples of that same thing. So if we are trying to learn a language, we have to see like a lot of examples of things about that language. I don't know if you get me. And if it was to be an apple, we need to see a lot of images of apple. But coming from language, like you said, we need to see a lot of vocabularies about that language, and also by repetition. That's how we learn, from my own point of view.
Yeah. it's a great point of view, and I agree with it. I agree with it. Another opinion on it? So, like you can see on the image, the model will help us to help the machine to learn from different vocabularies. For example, here, it's some vocabularies which will help a machine to learn. For example, it's raining, cats, and hands. There you can see those words are not correctly defined. It's just different types of words which will help the machine to learn vocabularies. And at the hub, you can see dog, rain, drops, fish, and wine. Those are words which will help a machine to learn. So definitely, what is an LLM? We can define it like an algorithmic basis from chatbots. So the capacity to give a machine to speak, the language capacity. And examples, we can talk about ChatGPT, we can talk about Google Bard, those kind of things. And a small information that we can get is that Google Bard has been built based on the model of PaLM. And this night, we're going to talk about PaLM, which is the large language model, which has been fine-tuned to learn to build Google's Bard. So the technology has been tied back to billions, even trillions of parameters. And those parameters are just words, vocabularies that we input on a machine. Like you can see on the picture, we input those words to a machine, and the machine will try to digest it and to give us back a word like we will see it together in next slides. So to make it simple, it's just a large language model. I think we can just make it simple. It's just like a big box where you input different vocabularies and you try to make some senses between different words. So the machine will learn all things inside this box, just like a big box with many words that you can see. So let's keep going through it. For example, here is an example of a sentence. Roses are red. How a machine can learn this sentence? What are three words the machine has to learn before giving us back this sentence? The three words are roses, are, and red. And also the comma. That's why I put in the comma. Because the comma, you can say that the comma is not a word. Yeah, it's not a word, but it's a character that the machine has to learn. So it will give it as a output for us when we want to learn it. Another one is violets are blue. And violets are blue is also another sentence the machine has to learn. But there is something interesting with those two words. Have you seen something different between those two words, two sentences? Have you seen something different? Something different that the machine has to catch before giving us back those two sentences. Something related on the sizes of those two sentences? Anyone have seen something? I really want this session interactive to help us to get the points. Benjamin, come on, please.
Okay, I think, is it the length of the characters or the length of the word? Hello? I don't know. Did you get me at all? Or can you guys hear me?
No, I didn't get you. Please.
Okay, I said, is the length of the word, the length of the characters?
Yeah. So together we have discovered two things. For a machine to learn about sentences, you have to care about the length of characters. You have also to learn about different words, the vocabularies. And also you have to keep in mind that all type of character in the sentence have to be learned from a machine before to give it as an output. For example, the comma at the end have to be learned from a machine to give it as output. So we have catch together that the machine has to learn about the length, have to learn about different words and also different characters inside the box. So let's go. Is more difficult. How a machine can learn this question? Anything specific inside?
It's like we lost you, Ato. I don't know, Mr. Dennis, can you hear him? I can't hear him anymore. Maybe his network or something. Oops. I guess his network kicked him out. Let's just wait a couple of seconds. He'll be back. He'll be back. Okay, Atokaza, you're welcome. It's like your network went off. You're welcome.
Mr. Jean Cassena, can you... Okay, that's fine. So sorry for the connection. I get some issue with it. Now I think it will be correct. So we were here, and I was talking about this question: how a machine can learn this question. What are different types, different. Put yourself. Learn this sentence, this question. You never heard about it. It's your first time to see it. How can you get this question? How can you learn it? The first thing, like we have said, it will be about different words. You, all, whence, marker, without me. This sentence makes sense. This question, does it make sense? Any sense? Hello, hello, everybody. You can interact with me.
For me, I don't know what record means. Just the confusion.
Jean Cassandra, you want to talk? Your mic, please. The session is recorded. It's not fine to make noises because the session has been recorded. It will be seen by 1,000 persons. Don't disturb, please. So, like I said like I was saying, this sentence have no sense. The specific word, makan, have no sense, but the machine will learn it. And another things we can put here as lights on is the sense. The machine learn, but counts in this step already cannot decide if a sentence has a sense or not. How a machine can decide this have a sense, this not have a sense? Any idea? Would have no sense. This would have a sense. I want us to get inside to the work that does LLMs. That's all the works of LLMs. LLMs not just help machine to learn, but also it help machine to decide if a sentence has sense or not. Let's keep going. We're gonna make it more clear here. Got the slide here. We have classic natural language problems. Those are big problems that LLMs have to face. They are entities extractions, classification, summarization, sentiment analysis, and translation. I'm going to give you a small example. Let me try. I will share with you a example of what a LLM try to do. Let me just stop sharing this. I will share with you a small example of what I'm saying. Where is it? The page? Yes. Yeah. This is a simple example of summarization. I don't know if you have already seen these tools. It's an amazing tools based on AI, based on LLM, which try to summarize text. Here I have put a text of an article I'm writing about AI. It's a specific article about scalability and data sharing. So I put all this inside. And I've said to this model, this LLM, to summarize for me this and to make it more short than all things I've written here. So I click here, and it gives me a summarize on less words than on less characters that I've put in the first year. But you can see when you are reading that the LLM has the challenge to keep the same how can I say it? The same sense of all things I've written here and to keep it here. It's a great challenge, but how LLM do those kind of stuff? How we make it possible? Let's go deep in our presentation to try to discover the magic behind it. This is a small example of what LLMs try to do. To make it simple, LLMs try to do predictions. Prediction based on great bases of what you have learned from the user. Here, a user tried to say, explain this joke. I used to be addicted to swap, but I'm clean now. What the model will try to, how the model will learn from this sentence. At the other side, you see how LLM, a model, think. The first thing the model will try to do is to understand the meaning of different words inside. The model, for example, the joke is a pun on the word clean. It has two meanings. First, to be free of dirt or another unwanted substance, to be free of addiction. And then the model will try to say which definition is the one I have to take to make this sentence really meaningful. So the LLM will make a prediction based on some probabilities to choose the best word at the best place. That's the magic what LLM does. And if we go deep on it, you will see different kinds of applications that and try tips of combination you can do when you think like LLM. For example, give 5 net ideas for science fair project. We can the 5 same options the 5 options I've given here. Build a volcano, make a solar oven, create a 3D printer, build a robot, design a water filtration system. This is fine. Till here, we have to understand and try to get ourselves inside how think and how LLMs try to put words to make prediction on what will be the next word to put there to make the sentence meaningful. That's the real stuff of LLMs. Keep in mind that these problems that classic natural language have to face are really deep and strong problems for LLMs. Because in each sentence, when you are chatting with ChatGPT or Google Bard, keep in mind that they have to face all those, they have to combine all those problems and to solve it quickly to give you the best answer. For example, when you are trying to say, hello, Bard, today I'm okay, what about you? You have to make a sentiment analysis to decide, this person who is talking to me, what is the mood today? Translation. Actually, Bard is available for around 40 languages, I think. So you have to translate different types of words. And actually, you can also take an LLM and make what we call a fine-tuning and also to try to apply it to another language. So I've talked too much. Let's go deep to see how we can chat a Firestore data now. Any question up to here? Any question? No. Let me keep going. Chats. Here is the problem. The problem is me. I have a restaurant. I need an application that can make for me request directly and recommend. How will I do if I'm a developer, I'm a programmer, I'm a software engineer? What will be the first thing I will think about? It's interactive, so let's come to answer, please. Any idea? If you have this problem, how will you try to solve it? in a classic way. You try to create, like I have written it, you can try to create a chat app. Then you can think, I have to vote inside the chat every words based on a box of words and sentence. I will help the application to learn before. So the application will put words and answer from the base of things I've learned to. That is a kind of solution that you can try to put up. But when you think about different questions, different menu that people can command, you will think about the optimal solution will be to use a LLM. Why LLM? Because the LLM will not just try to answer for the menu to make command, but also it will try to make the adjustment of people according to those classic problems. We make a sentiment analyze. This person, is it angry? You have any problem? So you try to put the person very quiet before him to eat and to make his comment. So how are we gonna face this problem? The first thing, the person have to make a description of what they need. The LLM have to think about different ingredients which will be made to answer to him. And the Firestore have to check about what is the price of each food the person have command and answer to him. It's not really simple. Here you have some example of the behaviors we want the application to have. How to make it possible? Here is the architecture, the things data scientists really love. First, the user inputs will be a question. And the cloud Firestore will be like this white black box. The white box, not black box, the white blocks, which will try to answer. And after it, we will give an estimation of the answer, and the model will put out the outputs of what we have done. So in the middle, what is happening? In the middle, first, at the Cloud Firestore, we had different menu. We have the menu inside. The menu inside, when a person asks for something, the application will try to put a link between each question to a specific thing inside the menu, and this will be bring as a specific parameter to our LLM, which will put it inside a sentence. And this sentence will be the output of the model. Another word you see here is MakerSuite. MakerSuite is a tool built by Google which will help us to make the prototype here, and will make it very fast. Let's prototype the idea with MakerSuite fast. I have made an introduction, so a fast, easy way to start prototyping generative AI ideas. It's really amazing. I just encourage you to go and see it and try it. It's really amazing. And MakerSuite have been present at the last Google EU, and globally is available with PaLM API, and actually is available for around 180 countries in use in English only, available. Yeah. And MakerSuite, specific things you have to know about it. You can take actually MakerSuite on production and support in production. So LLM powered chat application. will make the gesture of customer services, professional product recommended, a personal assistance, and a customer feed collection. This is the this is the big features we want the application to have. Here I've put it on Maca Threads. The template will have, look like this. You will put inside different command and different proposition, and inside I have also put a menu that will try to emulate. Let me copy the link here and put for you it's on the on the chat, so you can go to see at the same time. It's very easy to use. You have just to take time to check how to make some combination with words, and it will be more easy. Just go inside and look. You see, it's really amazing. It's really amazing. Just make some fun with Google AI Studio, and you will see it happening. In this step, we are doing what we call prompting. Prompting is a kind of trying to make a model learning. It's like a repetitor for a child. It's just like a teacher which is helping a small child to really learn with different conditions. It's like your English teacher. When your English teacher, with whom you have learned conjugation, you have learned how to make tenses and how to spell words. Prompting is just a kind of doing this. And when you are making prompt here, you are trying to help the machine to learn with different conditions. You said, for example, don't put this instead. You don't have to do this instead of. To do, add this menu based on this question, and after it, let's build it. But first, concept you should know. I've already passed it. I've talked about prompt engineering. It's the art of the science of writing input to give the LLM and it generate. Like I've given the example of the teacher which helped children to have grammaticals, to learn grammaticals, to learn tenses. And the vector is a little bit difficult to understand. It's a machine learning. When you call it embedded vector, which we call is like a representation of data as points, because all words, all characters have to be represented by some vectors, which will help us to. I will explain it more here. Here. I'm explaining vectors because, like I have said, the LLM has to do words. Each sentence the LLM will give like output, you're gonna try to make correspondence between a word with another word. It will try to make different prediction on what will be the next word to put here in this sentence. I put an I. What will be the next word to put here? Have it to be a verb, have it to be a country, have it to be a word. Which word will be the most suitable for this sentence to make it meaningful? Those are the kind of things a machine has to do. And to make it easy, a machine, the LLM, represents it like different vectors in a space. And those vectors have to be calculated. And it calculates what is the probability of this word to be predicted as the next word to this sentence. I know it's a small difficult to understand, but to make it easy, it's just prediction. And the LLM vectors. For example, here is a small example from our menu. You have the different menu. This food doesn't exist, so don't think there is a chicken chop, cheese, milileo, potato. It's just what I put in. So the machine has to make some correspondence. You put it inside a space and some correspondence. When someone asks for something which is liquid, which have a kind of color, black or white, with some things inside, it maybe it can be Michael Jackson on my menu. So I have to say, this customer have asked for a Michael Jackson. The machine have done a prediction. And to make this prediction, it put things on a space, and each parameters are represented as a vector. And the LLM, what it does is try to, for each vector, to predict the next move of the vector. Yeah, here it is. And it is the magic of our LLM, which is PaLM. In this case, there is a question like input, and PaLM will try to generate. And when it's trying to generate, it's gonna make some probability. What is the probability to have this? What is the probability to have this and so on? And then you're gonna say, this is the word I have to put there. Some code now. Some code. Let's code now. Have I to explain it for real? So import Google. So you have to import the key of the API and make some definition, some declaration, and you have to click to create the MB. What is very important for me here is the last line of code here. In this line, you are creating the vector, you are calling it. It's really important for me, because here is the trick, the magic trick for PaLM, is where you are trying to manipulate it. So vector similarity search. Why this concept is important? This concept is important because you have many combinations possible when you are trying to fix words. For example, when I say I am Arthur, there is also another possibility to say, hey, here is Arthur. You can also say, instead of saying, hey, here is Arthur, you can say, I'm Arthur. So what will be the suitable way to answer in each cases? I have a resource here. I think I will send to you it. Hello? Can you hear me?
Yes.
Yes.
Can hear you.
That's great. Okay. So I can go quickly through it. I know this is some different concepts. So let's go fast. Here is the demo of the application. So I will just copy it and send you to try it. Now you know. Let's look at how I've done it. So here is the Firestore collection. Here is the cloud function I've used. Cloud Cheluda. Here is the generating bidding. In this code, I call it here the last one here. Here it is. The last one there is where you call it. And there is the storage, the vector AI, vertex AI. I don't have time to explain all these concepts. Here is the code, the code. Here is my BD, my base, And here is the architecture of the document research. Let's keep going. Here also code. I don't have time to explain here. Here, this demo is an ameliorated version of the last one. The first one, I didn't have had the concept of